Today we will be discussing about unit number 2.3, that is charge controller. So in two sentence, how we can explain the function or the use of this charge controller. That is the panels, the solar photovoltaic panels, they can overcharge the battery by focusing too much electricity into it. Okay, during the high availability of solar energy, the sunlight, okay, the more energy will be generated and the battery may be overcharged. Okay, so hence a charge controller is required. Okay, so as to avoid this overcharging, because when battery gets overcharged, it gets hot and loses water rapidly, and this in turn damages the battery. A charge controller controls the charge by working similar to a valve on a rainwater collection system. Okay, what that does, it prevents the overflowing of the water tank. Similarly, the charge controller prevents the overcharging of the battery. Now, defining a charge controller. So, how to define it? The charge controller must be connected between the battery and the PV panels. So, here in the diagram, the solar photovoltaic panels, they are generating the electricity, and from there, the electricity that is flowing through the charge controller to the battery bank, then to the inverter, then to the consumer. Okay, so this is the place for the charge controller, where to connect it. The voltage of a battery is constantly under a check. The controller restricts extra charge from getting into the battery if a high voltage indicates full battery. Is battery charging that is indicated as full. After that, more charge will not be allowed to flow into the battery. The functions of a charge controller. The first one is charging the battery. Next is giving an indication when battery is fully charged. So it will control the charging. Also, it will indicate the fully charged battery. So monitoring the battery over voltage, and when it is minimum, then cutting off the supply to the load switch to remove the load connection. This is very related to the previous topic in the battery. We say it should not be the voltage or the energy should not be completely drained off from the battery. So this will prevent, our charge controller will prevent that type of situation, that the battery is not totally discharged. Okay, next, ensuring the load is cut off from the battery in case of overload. So this is also a safety feature, because of overloading, that is also damaging the system or the battery. This will prevent. So here the diagrammatic pictorial view of a functions of charge controller. Okay, solar panel, from there charging switch, and directly from solar panel to the indicator. So it will indicate the charging. Then charging switch there to the battery. So it is charging the battery. Next, setting. Sorry. Then from setting to the comparator, it will compare the voltage, how much voltage is there. If it is below the minimum, it is reached the minimum level, then it will switch off the load. If it has reached the maximum level, then it will switch off the charging. Then load switch. Through this switch, it will perform the switching operation. Finally, load switch to the load. The types of charge controller: series. Okay, first one, that is series switch, shutting the electricity flow off from the panel to the battery when full charge is attained. It is connected in series, that's why it is shutting or blocking the path. So switching usually done using magnetic switch known as a relay. Also some type of electronic devices like transistor, we can also use them. The next one is parallel charge controller. This parallel charge controller is connected along with panels placed side to side with their output wires. So they are not open, they will not open circuit, they will short circuit. Series charge controller, that will open circuit, it will open the series path. This parallel charge controller, as it is connected in parallel, it will short the path. So charge will not go to the battery. Instead, it will flow through this parallel path. Next is discharge controller. So this restrict appliances from intake of excess electricity from battery to avoid discharging it, because discharging is also done up to a limit. Above that, the life of the battery that decreases. So totally discharging of a battery, that is avoided by using this discharge controller. So it should be connected between the appliance and the battery. It works by keeping the battery's voltage under a constant check, because voltage that start decreasing when the discharge, the amount of a charge or the charge which can be taken from the battery, that is totally taken off. Okay, that is all. It means the battery is about to exhaust, totally drained, or totally discharged. So this will avoid. It will keep the charge flow from the battery within the allowed permissible safe range. So during low voltage, it shows a battery is completely drained, so the voltage starts decreasing at that point below the discharging limit. Okay, then next is combined charge and discharge controller. So they are put together in a same box and can be distinguished by looking their respective connections. The charge and discharge controller are in the same box. Okay, so their connections, their respective connections are there, and we make those connections from where we have to connect the this panels, from where we have to connect the load. So here, like in the diagram. So solar, battery, load, all of these connections, they are shown here on the charge controller. Technologies for charge controller. So basic charge controller ceases to charge a battery when they go beyond the upper limit of voltage level and begins to recharge when the battery voltage goes down to that level. Okay. With technological advancements in electronics, charge rates can be adjusted as per the battery level, allowing maximum charge capacity. That is a desirable condition, the maximum allowable capacity of the battery that should be utilized. Okay. Pulse width modulation charge controller. PWM charge controller function by matching the panel voltage to the voltage of the battery, and in the process bring down the output voltage of the panel. The pulse width modulation matches the voltage of the battery and the panel. Okay, then it comes into action when the battery is full, it's fully charged. Now overcharging, that should not happen. Okay, at the time of charging, it allows current as much as the panel can generate to reach the target. Once the battery reaches the target voltage, the battery is disconnected from the charge controller to avoid the discharging, obviously. Okay, ensuring efficient charging of the battery and protecting it from being overcharged. Next is maximum power point tracking. MPPT, in short, we call it as MPPT. So this type of controller is based on the latest technologies. Yeah, this one, a huge amount of research is being done in this field of MPPT to extract the maximum power from the solar panel. It aims at getting the utmost benefit from the solar panel. It functions as per the panel voltage and transforms the extra voltage of the panel into current. So this gives a boost to the solar panel's PV output. So they have controllers, they have indirect connection with the PV system and the battery bank. So it is linked to a DC-DC voltage converter. Okay, because in the output of the panel there is also DC, in the battery there is also DC. So a converter is used there. So what is the functions converter? That it changes the extra PV voltage into additional current without any loss of power. Okay, so adaptive algorithm, which they are using even more artificial intelligence, more advanced type of this algorithms they are being researched upon. We can find a very large number of research papers related to this MPPT on the internet. Okay, so they allow the MPP of the PV array and then adjust the input voltage to manage the efficient amount of power for the system, means efficiency that is highly increased. In modern inverters, this MPPT is installed. The cost of the inverter, MPPT inverter, that may be high from a normal inverter, but the efficiency it will give, that is very high. So terminology is related to charge controller. So for a charge controller to operate, various voltage and current levels are defined, like the nominal system voltage. This is the voltage at which the controller and battery operate in a PV system, the nominal voltage, rated voltage. the operating voltage, we can say. Nominal load current. This is the maximum load current the charge controller should be allowed to handle. Nominal PV array current. The maximum PV array current that this charge controller should be able to handle. So there is a safety factor 1.25. So this is for the adjusting the variation of the circuit. Maybe because of the standard conditions, the standard temperature, they are always not available. In that case, there is a range, safety factor range. The next, charge regulator set points. So it senses the battery's voltage to decide either to disconnect the source. Okay, in this case, source is the PV array, to prevent overcharging, or to disconnect the load to prevent deep discharging. With this charge regulator set points, check both upper as well as the lower limit of the voltage. So majorly it is used in cases of unpredictable loads and the batteries for minimizing initial cost. Okay, then these are set. So there are set algorithm threshold values, decision upon which they are taken. So threshold is just in a diagram. In our next page, we will see this type of limits. Voltage regulator set point. The battery's maximum voltage up to which it holds its charge capacity. Okay, at a threshold level, the controller either regulates the current received by the battery or disconnects it from the source. Next is voltage regulation hysteresis. This indicates the both maximum limit, minimum limit. Because voltage regulation hysteresis is the difference between the voltage regulation and the voltage at which the this voltage set point. What is the set point and the voltage at which controller reconnects the battery to the PV source and starts charging, means voltage is increasing. Okay, it has reached a maximum level. Then the controller has disconnected the battery from the solar panel. Now voltage start is decreasing. It may be feeding the load, charge is flowing out. Then immediately it will not reconnect the solar panel with the load. Okay, at some other voltage, less voltage, because voltage is decreasing from the maximum value, it is decreasing, and at that certain value, again this solar panel will be reconnected with the battery. So this range between the maximum value and the reconnecting voltage, at this point we are referring here in the voltage regulation hysteresis. And similar is the case with discharging. So low voltage disconnect, voltage decreases up to a certified maximum voltage limit. After that, deep discharging will occur that will adversely affect the battery. So the battery will be disconnected from the load by this controller. Okay, so the minimum battery voltage, that we call it as low voltage disconnect. Now, similar type of hysteresis is available for lower limit as well. This is the limit between the battery voltage and the low voltage disconnect, where the voltage are reconnected. Well, sorry, the load is reconnected. So what is happening? Battery is feeding the load. So voltage is decreasing. The charge is flowing out. Now it reaches a minimum limit, for minimum safe limit for the battery, and the charge is taken off by the load. At that point, the low voltage disconnect. The load is disconnected from the this battery. Then due to the solar panel, the battery is charging again. Immediately the load will not be reconnected up to some level. The voltage start increasing, it reaches some specific level. After that, the load is reconnected. So this duration, the minimum value and the reconnecting value, this is the hysteresis in the lower range. So here in the diagram, both of these values are shown in the charging as well as the discharging. So voltage regulation, that is the maximum point. Voltage regulation hysteresis, this is the range. Disconnecting and reconnecting the array. Next, in the discharging state, load reconnect voltage and the load voltage disconnect. Between these minimum levels and the reconnect value, there is a low voltage disconnect hysteresis. So they are not the same sharp limit. At the minimum voltage level, the load will not be reconnected until the voltage increases up to LRV, load reconnect voltage. Okay, so this shows the hysteresis. So charger commonly ratings which are being specified. in a charger, like the system voltage 12 volt, PVRA current 6 ampere. This is in reference for a PWM controller. Nominal load current 6 ampere, regulation voltage 14 volt, low voltage means all of these parameters they are specified. Low voltage disconnect, that is 11 volt. Then low voltage reconnect, that is 13 volt. So this is the hysteresis between 11 to 13. Okay, type of charging, okay, series PWM that we are studying it. Temperature minus 20 to 55 degrees Celsius and self consumption, that is 10 milliampere maximum. Okay, now features of a charge controller. So type of switching and control. Switching may be series or may be shunt as per our this requirement. The control algorithm may be used by a charge controller. It could be PWM or MPPT. Both of them we have discussed. So temperature compensation. It alters the charge regulation voltage as per the battery temperature. Okay, so it raises the regulation voltage when battery temperature is very low. This improves its capability to charge the battery. Temperature is low, then the voltage regulation can be increased. It, on the other hand, it lowers the voltage regulation when the temperature of the battery is high. It helps to reduce the loss of electrolyte because in high temperature, the battery loses electrolyte, gets overcharged. So in that case, it will reduce the regulation voltage. The lead acid battery has a standard temperature compensation coefficient of -5 millivolt per degree Celsius. Now, few charge controllers have the provision of equalization function. So both manual as well as automatic. So this is the advanced one. Manual there for our reference and advanced one, that is the automatic. So it will adjust itself so as to ensure the maximum charge storage capability and the maximizing the life, the performance of the battery. So yeah, other function is indication for system status and operating information. So it indicates the system status, the operation which is being performed. So here on the in the image there is a indication. So there are lamp lights, small LED lights there. Through this we can check the status. Okay, the set points of the charge controller specify the voltage level of the controller to perform, regulate, and control functions. So these are important parameters affecting the life. Yes, because the life of the battery that increases with proper maintenance. So charging that is within the limit, temperature that is maintained. Although temperature totally is not in our control because of the environmental reasons as well. Okay. Now, few charge controllers have battery voltage sense leads to oppose the after effect of voltage drop on the charge regulation set point. It is shown here in the image. So charge controller, so sense power both positive and negative. So that is here connected with the battery. So it is sensing the voltage of the battery. The next topic is wiring and maintenance of a controller. So correct wiring, that is yes very important because many like the combined controller is there, so it is performing the charge of both functions of both, like the charging controlling as well as the discharging controlling to the load as well. So wiring, if it is not proper, then it's a function totally it will be affected, maybe damaged as well. The controller should be wired in the circuit as per the instruction provided by the supplier of the controller. So manual is provided by the supplier, and as per the instructions given in the manual, the similar type of connections we have to make, like the positive terminal of the battery should be connected to positive for the controller as well. No interchanging. Like the controller should be strongly mounted in a cool place away from the sun. Another precaution we should take. Not in direct sun, we should not take it. Rain, that should not be directly reaching that point. So it should be properly shaded from the sun, from the rain, and it should be placed near the battery. So controller should be placed where indicators are visible. So it is not like that we have placed the controller, but we are not able to see the indicator. So we won't be getting the condition, so the status of the our system battery or the battery, mainly the battery status. Okay, so long wires, usually this could cause a adverse effect. So it should be approximately 1 to 2 meter from the battery. So Another precaution is ensure installation of an earthing system and that all installation steps are duly followed. So lightning is a major damaging agent of semiconductor switches. With a circuit to disperse generated electricity from lightning is included in charge controller of good quality. The controllers must be equipped with a wire earther properly using an earthing rod, means earthing of the system. That should be properly checked because that is very much needed to is to place a given alternative path to the in case of a lightning. Okay, so alternative path should be there. It should not directly enter our system. Okay, so that is if it is earth, then the extra charge the lightning due to introduced to lightning, the extra charge that will go to the earth. A mount or PV panel frame is essentially required in some installation for an earth connection. Next is avoid changing controller adjustment. The adjustment indicated a full or discharge. So without appropriate equipment or techniques, adjustment can't be correct. So any change in adjustment without proper equipment techniques may result in a battery's damage. We have adjusted like manually, we have adjusted some type of setting, but that is not proper, not within the safe limit of the battery. So that will damage the battery. Now next is ensure a correct wiring. So incorrect wiring, they can damage the controllers. Okay, other factors like water, insect, heat, and animals. Okay, then we should carefully add new appliances to ensure a controller handles extra power without damaging itself. So in case of a serious damage to controller, we shall replace it, the controller.